Example 5 is quite similar to example 4. However, the way that we set our equations up is a little bit different. So how do we approach this sort of question and know to make a connection to sum of the roots, product of the roots? Again, it's simply because it mentions that we've got a quadratic. We can see we've got a quadratic, and it's talking about a root. One root is double the other. Find the value of k. That doesn't help us make a connection at all. It would really just be the fact that it says it's a quadratic equation and it's mentioning something about the root of the equation. So that's not a lot of help or hint for you to make the connection. So in each question you do in this exercise, try to think about the wording of the question and use that to build a bank of questions for yourself that you know lead you to sum of the roots and product of the roots. Like I said, it's very similar to the previous one. You're being asked to find the value of k. Anytime we want k, any variable that we're finding, we know that we would ideally like an equation with k in it, and so find k tells me I want an equation involving k that I can solve. So we use the ideas about roots and quadratics to form equations. So from the quadratic, we know that a is equal to 2, b is equal to minus 3, and c is equal to k. We also know that one root is double the other. So if I let alpha be one of the roots, the other root is double this. 2 alpha is the other root. Now, that's what I meant in the beginning when I said the way that we're going to set our equations up. We're going, we're not, although we've got 2 roots, because we know a connection between those two, then we're going to use that rather than introduce the beta for our second root. That's introducing something that's unnecessary given this information. Okay, so what do we know? We know that the sum of the roots, alpha plus 2 alpha would be the sum of the roots, is minus b on a, which is 3 on 2. So we've got that 3 alpha is 3 on 2. 3 2s is 6, alpha is 3, alpha is a half. Therefore, the other root, is 1. And what do we know about the other root? And we still need an equation with k in it. So k appears in the product of the roots. So also the product of the roots, which is alpha, no it's not, it's alpha times 2 alpha, is c on a by definition, but c is k, a is 2. So I've finally got an equation with k in it, but we also know the value of alpha and 2 alpha. So we've got alpha is a half and 2 alpha is 1 is equal to k on 2. So we've got that k is equal to 1, I think. Yep, 2 on 2 is 1, k is equal to 1. You could always sub it back in. find the roots and show that using k is equal to 1, you get two roots where one is twice as big as the other. Again, I'll stop the video there and do the last example in another video.